Good morning to all. So yesterday lecture we have started measurement of temperature, pressure and vacuum. In that measurement of temperature, first point is covered. There is a thermometer. See the diagram of thermometer. Two types of liquids are used: mercury and alcohol, 210 and pentane. So mercury range minus 37 degrees Celsius to 356 degrees Celsius, and alcohol 2N and pentane range minus 200 degrees Celsius to plus 78 degrees Celsius. So yesterday's lecture, you all of you draw this diagram. So today start writing the description of thermometer. Okay. So write down first point in thermometer. It is the most common type of thermometer. It is the most common type of temperature measuring device. Next point, second, full stop, second. It consists of glass envelope, a responsive liquid, and indicating scale. It consists of glass envelope, a responsive liquid, and an indicating scale. Full stop and next line. The envelope compresses a thick walled glass tube with a capillary bore and a spherical or cylindrical bulb filled with the liquid. Filled with the liquid. Stop and next line. The thermometer bulb is usually filled with mercury it has the advantages of a broad temperature span, between its freezing and boiling point. Between its freezing and boiling point. Full stop and next line. However, in many industrial applications, to escape mercury through breakage causes considerable damage to the product. Sir? Full stop and next line. This may necessary to use other liquids such as alcohol, pentane, and toluene. These liquids are also used for temperature measurement below the freezing point of the mercury. Below the freezing point of the mercury. Next heading, second temperature measurement instrument is thermocouple. Give the heading thermocouple. And draw this diagram of thermocouple. All of you draw this diagram. Second temperature measurement instrument or device is thermocouple. So I request all of you to draw this diagram. Okay. See the diagram of thermocouple. Here two metal wires are used. Two different metal wires are used. One is connected for hot junction and one is connected for cold junction. Here connection arranged with the connected to the voltmeter. There is a heat source. Heat source passes the heat, and this hot junction consumes the input supply heat and passes through the here and measure the voltage. Also, this heat transfer to this side to the cold junction, and this cold junction also connected to the voltmeter. Okay, here. So electromotive force, EMF, 1.2 and third, T1, T2, and T3. Here, this is two different metal wire, M1 and M2. Electromotive force, E1, electromotive force, E2. Here, T1 to T2 and T2 to T3. The EMF generated in thermocouple with junction at the temperature T1 and T3 is equal. T1 and T3 is equal is sum of two thermocouples. Okay. Similar thermo, one acting between temperature T1 and T2 and other acting between T2 and T3. Where T2 lies between T1 and T3. Here E1 and E2. So E1 plus E2 is equal to T3. Additive temperature intervals. Okay. Also draw this diagram. Thermocouple also known as the law of intermediate temperature. Also draw this EMF diagram. Write down the details of thermocouple. Okay. Write down first one. When two conductors of dissimilar metals, when two conductors, TW, two conductors of dissimilar metals, capital M1 and capital M2, are joined together to form a loop, in bracket a thermocouple, and two unequal temperatures T1 and T2 are imposed at the two interface are imposed at the two interface connections, comma, and electric current flow through the loop. Full stop. Roll number 6. A division. Any problem? Thomas G. Okay, no problem. Full stop and next line. A thermocouple is capable of measuring temperature in the range minus 200 degrees Celsius to plus 2500 degrees Celsius. Get it? Full stop. Next line, write down title. Law of intermediate temperature. Law of intermediate temperature. Write down. The EMF generated in a thermocouple the EMF generated in a thermocouple with junction at temperature T1 and T3 is equal to the sum of EMF generated by similar thermocouples. One acting between temperature T1 and T2, one acting between temperature T1 and T2, and other acting between T2 and T3. Draw this diagram. Write down. If the thermal EMF of any metals with respect to a reference metal with respect to a reference metal in bracket such as M3 are known, the EMF of the combination of two metals, the EMF of the combination of two metals is the algebraic sum of their EMF, the algebraic sum of their EMF against the reference metal. Against the reference metal. Next means third temperature measuring device is RTD, resistance temperature detector. RTD, give the heading RTD, resistance temperature detector. I request all
Sir,
of you draw this diagram under the heading RTD, resistance temperature detector. Here resistance element is there. This is laboratory type resistance element and this is industrial type resistance element. Okay. Draw this diagram under the heading resistance temperature detector RTD. Okay. Here, resistance temperature detector RTD. See the diagram. R1, R2, and R3. Three different resistors are used. And here, resistance element means this laboratory type or industrial type resistance are connected to detect the temperature and measure the actual temperature flow in the circuit. Here, two resistance R1 and R2 connected in a series, and this R1 and R3 is connected to the parallel. Uh, at the time of sensing the temperature, series connection are used. Okay, and here power supply is there. Laboratory type and industrial types are two different resistance are used to measure the temperature, because in laboratory type resistance element senses the temperature range is below 100 degrees Celsius, and industrial type resistance is temperature sensing temperature range is 100 to 1000 degrees Celsius. Okay. See the temperature range of RTD minus 200 degrees Celsius to 500 degrees Celsius plus. See the description. The thermometer compresses a resistance element or bulb suitable electric leads and indicating recording the resistive measuring instrument. The resistance element is usually in the form of coil of very fine platinum, nickel, or copper bound non-conductively into an insulating ceramic former, which is protected externally by a metal shell. Here, this is the platinum sensing coil and glass or proximal, and these leads of aluminum wires. The change in resistance is usually measured by a Wheatstone bridge, may be used either in the balance condition or in the deflection out of the balance condition. Here, here R1, R2 connected in a series and R1 and R3 is connected to the parallel. The balance and unbalanced condition are used to measure the sensing the temperature. The change in resistance is usually measured by a Wheatstone bridge, which may be used either in null means balance condition or in the deflection out of the balance condition. This is the advantages of RTD: simplicity and accuracy of operation, possibility of easy installation and replacement of sensitive bulb, then easy check on the accuracy of measuring circuit by substituting a standard resistance for the resistance element. And disadvantages of RTD: resistance change due to the temperature changes of the measuring resistors. Here two resistors are used, one is laboratory and other is industrial resistance. So due to this changing resistors, temperature also will be changes. Possibility of current leakage between the resistance element and the ground. Some possibility to leakage the current between the resistance and the ground. Okay, so write down the description of RTD resistance temperature detector. A thermometer compresses a resistance element or bulb suitable electric leads and an indicating recording or resistance measuring instrument. Full stop and next line. The resistance element is usually in the form of coil of very fine platinum, nickel, or copper wound non-conductively into an insulating ceramic former which is protected externally by a metal shell. Full stop and next line. The change in resistance is usually measured by a Wheatstone bridge which may be used either in the null balanced condition or in the deflection bracket unbalanced or out of balance condition. Full stop. Write down advantages of RTD. First one, simplicity and accuracy of operation. Second, possibility of easy installation and replacement of sensitive bulb. Possibility of easy installation and replacement of sensitive bulb. Full stop and next line. Easy check on the accuracy of the measuring circuit by substituting a standard resistance for the resistance element. full stop. Disadvantages of RTD, resistance temperature detector. First, resistance change due to temperature changes of measuring resistors of measuring resistors. Full stop. Second, possibility of current leakage between the resistance element and the ground and the ground. Full stop. And today's stop here. Division A, place your roll number and leave the meeting immediately. Division A, Division A, place your roll number and leave the meeting immediately. Division B, place your roll number and leave the meeting.